Hi, I'm Jacob Vaverka, Sales Engineer at Julia Computing. We're going to take a look today at JuliaSim's latest offering, the FMU Accelerator. There are two ways for JuliaSim to add value: by accelerating existing systems and by providing a complete platform to build and scale dynamic models. Let's take a look at the former in a real-world application of HVAC modeling. It can take over 1,000 runs to train a controller for an industrial building. If one run takes 10 minutes, then the full training process now takes 2 weeks. These timeframes decrease productivity and limit the time for discovery in the design process. JuliaSim offers an answer to this problem with its wide platform and FMU acceleration, and it's already had success in the real world. Here's an example of a Dymola model with 8,000 equations where a pure Julia implementation offered a 6 times speed up. Surrogatization on top of that offered almost another 100x. So in total, we're able to achieve a 570 times speed up. Another example, ramping up the number of equations to 100,000, we see an 80 times speed up on the Julia baseline. And these methods can be applied to many domains. Here we're looking at a circuit model that received a 274 times speed up using the same techniques. We're also able to apply these methods to QSP, or quantitative systems pharmacology, and this is an example where Julia, just vanilla plain Julia, was already outperforming the existing tools, and when we apply the surrogatization techniques, we instantly get 100 times speed up, and there's probably still more on the table. We're going to take a look at how JuliaSim is exposing a lot of these methods and capabilities through a GUI application, and we're going to do this by taking a look at an example where we see the influence of armature temperature on a DCMP motor. So let's see the app. We can go over to JuliaHub and launch this just like any other app. We can select the type of compute resource that we want to spin up for this application. One note is for the FMU Accelerator, the compute resource that you choose will not affect the surrogate training time. That's going to auto scale depending on the complexity of your model. After we decide what we want to configure, we can go ahead and start that instance up. And once it's ready, we can connect. Welcome to the FMU Accelerator dashboard. Let's go ahead and start a new job. Load an FMU by dragging and dropping a file, hitting continue, and now we're ready to configure our parameters. So let's go through the different options that we have. We'll start with algorithm. We'll select linear here. Next we'll choose the reservoir size. Remember, this is the number of nodes, and we'll set this right around 500. Number of sample points, or the number of simulations. This is pretty simple, so we're going to keep that low. Then we can select the time span. We'll do a start time of 0, end time of 3, with a time step of 0.1. And then we'll move on to the parameter space. Here we can select a parameter. Choose the lower bound, the upper bound, and the sample value. And this sample value is what we'll see in the diagnostic reports later. We can also add parameters, and from here we can pick any parameter. We know all of the parameters included in the model from when we loaded the FMU. Now we're going to reset these options, and then we're going to load in a configuration that has everything we need in order to run this example. Once that's loaded, we are ready to hit surrogatize and kick off this job. And as soon as that job is started, we're back at the dashboard. Now you can see progress says that we're unpacking parameters. This job is going to move through a few different states. First, we're going to set up the simulation, then compute surrogates, then we're going to generate diagnostics, finally generate the FMU, and then the job will be complete. As the job progresses through its states, we'll have a chance to open up the diagnostic report. We can choose to download it or view it in the browser. So the ability to train these surrogates is really cool. What's really important as well is that we understand what we're getting out of this new model, and this diagnostic report is going to help us understand that. So first we start off, we get some summary data over the parameter space that we defined, the time span that we defined, and the number of samples that we selected. Moving on to this section, we can really start to take a look inside how this model is performing. Now, first thing you're going to notice is this color bar on your right. This represents the relative error. So yellow is a small relative error, purple is a high relative error. Each vertical axis corresponds to a model parameter that we can see down here. And immediately the purple lines stand out. So this is a high relative error, and this helps us see where this model performs poorly compared to all the yellow lines where the model performs very well. Now, already you can gain a lot of insight just from looking at this model, but we have the ability to interact with this model, with this graph. So I can slide so that we take a look at just the percent error from 0 to 15. And here we see a large, a very dense pack of values of high omega, medium to low gamma, etc. You can start to understand how this model is performing at different values for your parameter space. And the same is true in the opposite direction. We can start to filter out some of this noise and understand where this model performs poorly. Now, when we're using this, it's important to know, right? We need to understand when it's a good and a bad fit to use this model. So this is such a good, clear way, I think, to help get a little bit of insight into that black box process of the surrogate training. And as we go down here, we see that we can also see the accuracy in this chart for each of the parameters. Now these are sorted. We're going to see actually the parameters and their states. And so here we are looking at very high accuracy. And as we move this slider, we're going to start to see some lower accuracy in some of these points. And if you want to, you can delve deeply into each of these different combinations and further understand your model. And once the job has reached a completed state, we can go ahead and download the accelerated FMU. And so that's it. We've walked through a small, simple case. And what I really want to stress here is that this can be even more beneficial on large models. So on a big model where there's a lot of complexity, this process can really strip a lot of that away, cut down time, and still leave you with a high fidelity model. And remember, anyone working within the FMI standard can use this. So there's no need to learn a new framework. This fits right in with your existing workflow, and we're excited for you to try it. Thank you for your attention.